Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we're looking at equations with infinitely many solutions. Previously, we looked at inequalities, which also have infinitely many solutions. But here we'll look at equations with infinitely many solutions. So this equation here is linear because the pronumerals only have a power of 1. There's no squared, square root, anything like that. So this linear equation has infinitely many solutions because it has two variables or two pronumerals. You can pick literally any value you like for x and there will be a corresponding value for y. So for example, x equals 5, y equals 1 is a solution because if I substitute x for 5 and y for 1, that makes a true statement. 1 does equal 5 minus 4. That's true. You can pick heaps of other ones. You can pick x is 10, y is 6. That is another solution. 6 equals 10 minus 4 is a true statement. Of course, the solutions don't have to just be positive numbers. They could be negative. You could have, for example, x is negative 3, y equals negative 7. That's a valid solution. The solutions don't even need to be whole numbers. For example, you could have x equals half or 0.5, y equals minus 3.5. That's a valid solution as well. There are infinitely many such solutions. So each of these solutions is an x and a y value that substituted into this equation make it a true statement. So if you were asked to come up with any solution to this, just pick any value of x and find the corresponding value of y easily. Another equation that has infinitely many solutions is this one here, 0x equals 0. Because if you times 0 by a number, you will always get 0. So you will get x equals 2 as a solution. 0 times 2 is 0. You could have x equals negative 5. You could have x equals 0. The solutions don't need to be whole numbers. 7.75, for example. Literally any value of x will solve this equation. So when do you have equations, or linear equations in particular, that have infinitely many solutions? So you have it when you have one equation, one linear equation, and two variables. That will always give you infinitely many solutions because you can choose whatever you want for the first variable and find a different value for the other. The other time you get infinitely many solutions is a bit pathological. It's when an equation is equivalent to 0x equals 0. That gives you infinitely many solutions because 0 is kind of like a special case. All right, let's now look at equations with infinitely many solutions, but when we're just interested in integer solutions. So each of these is a linear equation and each has infinitely many solutions because both equations have two variables. We're going to turn our attention to looking at only solutions where x and y are both integers, both whole numbers. So if we look at this first one, it turns out that there will be no integer solutions to this. There will be no solutions where x and y are both whole numbers. Why is that? Well, think about it like this. 3x is always going to be a multiple of 3 as long as x is an integer. When you times a whole number by 3, you get a multiple of 3. Similarly, any multiple of 12 is a multiple of 3. 3x, 12y, if x and y are integers, this must give you a multiple of 3, but 4 is not a multiple of 3. So there are no integer solutions. It turns out you can determine whether or not there will be solutions pretty easily. This number has to be a multiple of the highest common factor. So this number here has to be a multiple of the highest common factor of these numbers in order to have integer solutions. So 3 and 12, the highest common factor is 3. This is not a multiple of 3. There are no integer solutions. Now if we look here, the highest common factor of 4 and 7 is 1. Well, 2 is a multiple of 1, so this will have integer solutions. So how are we going to find these integer solutions? Well, let's just look at multiples of one of these numbers that is 2 more than a multiple of the other. So for example, if we go through the multiples of 4, we can just write out a few. So we got 4, 8, 12, 16, 20. You can keep going as much as you want. For 7, we've got 7, 14, 21, 28, and so on. Notice here that we have 4, a multiple of 4, that's 2 more than a multiple of 7. So we can have 16 minus 14 equals 2. We know that. We wanted this to be a multiple of 4 and a multiple of 7 because 16 is 4 times 4 and 14 is 7 times 2. But of course, we can write this as 4 times 4 plus 7 times negative 2. Exactly the same thing. So we've just found an integer solution. X equals 4, y equals negative 2. That is one such integer solution to this equation here. So if we have one integer solution, we can find infinitely many more. How would we find another integer solution? Well, let's look at what we've done here. What we can actually do is use the lowest common multiple. So the lowest common multiple of 4 and 7 is just 28. Remember, the lowest common multiple of two numbers, you multiply them together and divide by their highest common factor. So we can take our equation here and we can go 4 times 4. We can add 28, the lowest common multiple, and then subtract 28. If we add and subtract 28, we're really not changing the equation. So how does that actually help us? Well, we can write 28 here. We can rub that out and write it as 4 times 7. And of course, this minus 28 here, we can rub that out and we can write it as 7 times negative 4. So what do we actually have here? How does that help us with another solution? Well, let's look at the first two and the last two. 4 times 4 plus 4 times 7 is the same as 11 times 4. So here we have 7 times negative 4 plus 7 times negative 2. That's the same as 7 times negative 4 minus 2 is negative 6. So we've just found another solution. That solution here is x and y. That solution is x equals 11, 4 times 11, and then 7 times negative 6. That is another solution. So figure out if there are any integer solutions by making sure that this number is a multiple of the highest common factor of these two numbers. Then to find the solutions, find multiples of this number and this number whose difference is this number here, and then you can use the lowest common multiple to find additional solutions. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a nice day.